Hi, this is John Linneball, and this is Barron's Premium SAT Guide, Imaginary Numbers. I'm with John Linneball Tutoring, and here is my contact information. This will also be at the end. All right, so we're dealing with imaginary numbers and complex numbers. What we're covering here are the questions in the Barron's Premium SAT Guide. That's the 30th edition of the Barron's Guide on page 695. This will also work for the 28th and 29th editions. If one or two problems are different, I apologize in advance, but I'm pretty sure they're the same problems. What do I need to know about imaginary numbers for the SAT? And if you like this video, please don't forget to give this a thumbs up, subscribe to my channel, and click on the little bell in the top right corner for notifications. These instructions, of course, apply to YouTube, so if you're watching it on Facebook or another platform, please check out my YouTube channel, John Linneball Tutoring. You'll see a little picture of me next to a cardboard cutout of Austin Powers. That is Michael Myers as Austin Powers. All right, here you go. Who should watch this video? Anyone who's studying for the SAT using the Barron's SAT book, the one that covers the whole SAT. It's called the Premium SAT Guide in the 30th edition. It's Barron's SAT before that. And then, anything from Barron's new SAT up to here would work just fine. Okay, so if you don't have a copy of a Barron's SAT book, you really should get one. These Barron's answer videos don't cover everything you should know for the math SAT. Basically, my other math videos do come close, and they cover a lot of things, but it's still a good idea to get a comprehensive SAT review book, and Barron's is the one that I use with my students. Also, there are some things that are covered in the actual chapters that aren't necessarily in the review questions at the end of the chapters in the Barron's book. So do yourself a favor, get one. Even if you get a 28th or a 29th edition, that's just as good, and you can probably get it for $2 plus shipping. So you get something that was originally about a $30 book for about $5, $6 maybe, or I don't know, maybe it's only a $20 book, but still, it's a good deal. Some libraries even have sales where you can buy books that they're going to throw away for a dime, and those do include SAT review books. So really, the book's cheap, go get one, and no, I don't get any money if you buy a Barron's book in any edition. I just like those books. I use them with my own tutoring students. So question 1 on page 695. If a and b are real numbers and ai squared equals bi to the fourth, which of the following must be true? Must means necessary. May means not necessary. That's a great lawyer word. We may do this. Well, that means we may not do this. Must means it has to happen. You have to do it. Or especially if you speak Spanish as a first language, you might say you need to do something. They say that a lot in the western United States where I live right now, as opposed to in the eastern United States where I grew up. So, a equals b. Well, let's take a look at that one. We know that I squared is -1, so I cubed would be -I, and I to the fourth would be -I squared, which is -1, which is just 1. Remember, a double negative is a positive. So a is equal to -b, so we know 1 is not true. Follows that 2 is true because we just proved it while we were disproving 1. And 3 must be true since if numbers are opposites, that is, a is equal to -b or b is equal to -a, then, if they're negatives of each other, they have the same absolute value. That is, they're the same distance from 0 on the number line. So 2 and 3 are true. Which of the following is a negative number? A is I to the 33rd, B I to the 50th, C I to the 63rd, D I to the 80th. We know that I to the first power is just I. Anything to the first power is itself. So that's equal to the square root of -1. So I squared is equal to -1. I cubed is -I, and I to the fourth is 1. And then you take I to the fifth, you're just going to end up with I, because 1 times I would have to be I, since 1 times anything is that thing. So we divide each exponent by 4, take the remainder, and count. So a, 33 over 4 is 8 remainder 1, so it's I to the first, which is I, which is neither positive nor negative. Imaginary numbers are just imaginary. They're not positive or negative. B, 50 over 4 is 48 remainder 2, so it's I squared equals -1. Ding, 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 here's the answer. Let's check the other ones anyway, but don't bother to do this on the actual SAT. Once you know you've got the right answer, you don't need to look at the other answers on a math problem. 63 over 4 is 15, remainder 1, so it's the same as A. It's going to be 1. And 80 over, or it's not going to be 1, it's going to be I, I'm sorry. So C is the same as A, which is I. So that's imaginary, not neither positive nor negative. And D, 80 over 4 is equal to 20 with no remainder, so it's I, which makes it the same as A. So A, C, and D are all just I, which is imaginary, neither negative nor positive, but B is negative. And I would like to comment on my statement about checking the answers. You should check all the answers on a reading question or on a grammar question. So on the English reading test, do check all the answers because they're looking for the best one. Same thing goes with the writing test, where you have to go through the long passages and correct those. You really should look at all the answers really quickly. And also the wrong answers are actually kind of funny. But with the math ones, once you find a right answer, just check it to make sure that you've answered the correct question. And then once you're sure of that, boom, you're done. Okay, let's move on to the next question here. Question 3, page 695. Which of the following is equal to 1 plus I to the 4th power? Well, let's evaluate this. The easiest way to do this is break it up into I plus 1 squared times I plus 1 squared. So I plus 1 squared is equal to 1 plus I times 1 plus I. All right, so we can easily evaluate that using FOIL, first, outer, inner, last. I know some of you watching this like to use super diamond, whatever. You know what? I don't really know how to do that. I know FOIL, so I'm going to use FOIL. So first, 1 times 1 is 1. All right, outer, 1 times I is I. And then I times 1 is also I. That's the inner. And then last is I times I, which is I squared, which is just negative 1. So you add them together, you see 1 minus 1, that's 0. I plus I is 2I. And remember that I squared is equal to negative 1. That's where this negative 1 came from. So now we just multiply 2I times 2I. Since we evaluated this once, we don't need to evaluate it again. We're just going to square it. So that becomes 4 times I squared, so that's 4I squared. I squared is negative 1, so that's negative 4. So that's answer A. Question 4, page 695. If A and B are real numbers, which is equal to A plus BI times A minus BI? Remember the difference of squares where A plus B times A minus B is A squared minus B squared? Well, these are complex conjugates, and they work pretty much the same way as the difference of squares, but since we're using complex numbers, which is A is a real number, B is a real number, I, of course, is imaginary. So this is the imaginary component, this is the real component, this is the imaginary component, this is the real component. So these are called complex conjugates, A plus BI, A minus BI. So you can see there's a conjugate, there's a conjugate. So they're conjugates of each other, so they just go around in a circle like that. So 2 plus I, complex conjugate is 2 minus I. Negative 3 plus 7I, negative 3 minus 7I, complex conjugates. 6 minus 4I is the complex conjugate of 6 plus 4I. So anyway, when you do FOIL on these, okay, you get A squared, boom. You get minus ABI is the outer, plus ABI is the inner. So you can see those cancel out. Minus ABI plus ABI, that's going to be 0. And then minus BI squared, so that's just going to be minus B squared, then minus times I squared. Remember, I squared is negative 1, so that's going to become minus B times negative 1, so it becomes plus B squared. So you end up with A squared plus B squared. So this is going to be minus B squared times I squared. So again, it becomes positive B squared. So we have A squared plus B squared. So it's just like the difference of squares, but this becomes kind of the sum of squares because we're dealing with the square root of negative 1I here. So that's choice B. Question 5, page 695. If A, B, C, and D are consecutive integers, what's the value of 1 to the A plus 1 to the B plus 1 to the... I to the A plus I to the B plus I to the C plus I to the D. Wow, that sounds hard. Well, it is hard until you realize that it doesn't matter what integers they are. They just have to be integers. So you know this is going to be A. And if they're in order, then this is going to be, well, they are consecutive. So this is A plus 1. This is A plus 2. This is A plus 3. So you know that one of these is going to have to be I. So let's say this A is 1. So this is going to be I. This is 2. That's negative 1. It's, because it's I squared. This is 3. That's going to be negative I. Okay, so I and negative I cancel each other out. And then I to the 4th is going to be negative 1 times negative 1, so that becomes 1. So we have negative 1 plus 1. That becomes 0. So we get, it's going to be And we have I, this should be a small I, oops, made a typo here, probably auto-corrected it to capital I. So I plus minus I is 0. -1 plus 1 is 0. So that's just choice A. Question 6, page 695. If I to the m equals I to the n, which of the following must be true? 1 is m equals n. That does not have to be true because it can be true. I mean, m could be equal to n, and obviously I to the m would be equal to I to the n. But as we've seen, two powers of I that give the same value can also have a difference that's a multiple of 4. So, for example, I to the 1 is equal to I to the 5. And then let's address the next issue here. M plus n is even. Well, for any integers q and r, okay, then q plus 4r, so that's 4 times any integer, and q is any integer, is going to be 2q plus 4r. 2 times any integer is even by definition because 2 is a factor of it, and 4 times any integer, again, it's 2 times that, so 2 is a factor twice. So obviously, both 2q and 4r are even. When you add an even to an even, you get an even. You can plug in numbers if you don't believe me. For example, 2 times 3 is 6, and 4 times 5 is 20, so their sum is 26, which is also even. And n minus m is a multiple of 4. You bet, we've already seen that before. So since m is not necessarily equal to n, but 2 and 3 are obviously true, 2 and 3 are true, so C is correct. Question 7, page 695. If a plus bi times c plus di is a real number, which of the following must be true? First, we use FOIL. We get ac, because a times c, that's the first. Then outer is ADI, so ADI. Inner is BIC. We can rearrange that to BCI, so it looks better, and it also makes it easier for us to do the next step. And then BI times DI is going to be BDI squared. Remember, I squared is -1, so that just becomes -1 times BD, so it's the same as just minus BD. So we can factor and combine like terms to get, okay, AC minus BD, we combine those, and then ADI plus BCI, we just factor out the I, so then put AD plus BC in parentheses, times I, that's equal to E plus FI. So for some real numbers E and F, so we know AC minus BD is equal to E, AD plus BC is equal to F. Well, since we know this whole thing is equal to a real number, we know that E plus Fi has to be equal to E plus 0. Why? Because it's a real number, and when you're expressing a real number as a complex number, we know the imaginary component has to be 0, because a real number can't have an imaginary component, otherwise it would be a complex, it would be a complex and an imaginary number. So if we express it as a complex number, the coefficient of I must be equal to 0. Therefore, AD plus BC is equal to 0. So AD is equal to minus BC, because we just subtract BC from each side. That's choice D. Question 8, page 695. If 3 plus 5i over 2 plus 3i is equal to a plus bi, what is the value of a plus b? Well, what we do first is we have to express the division. If you're looking at your Barron's books, they use the little line with a dot on the top, dot on the bottom. I couldn't find that on my computer, so I just drew it this way. Anyway, we express the division as a fraction, so we have this divided by this, and then we multiply the complex conjugate of the denominator divided by itself. So complex conjugates, remember 2 plus 3i, the complex conjugate is 2 minus 3i. We do that of the denominator, and we have it on the top and the bottom, so this is 1. Since it's the same thing on the top and the bottom, this is equal to 1, so we know we're not changing this at all by multiplying it this way. Okay, so 2 plus 3i times 2 minus 3i, that's just 2 squared, and plus the 3 squared, so it just becomes 4 plus 9, so that's 13. And then the top, okay, 3 times 2 is 6. That's the first. Outer is going to be 3 times 3i. That's minus 9i because it's minus 3i. So 3 times minus 3i. Then 5i times 2 is plus 10i. And then 5i times negative 3i is going to be minus 15i squared, which is the same thing as just plus 15 because it's going to be minus 15, so that's plus 15. So, okay, we're going to have 6 plus 15 is 21, and then 10i minus 9i, or minus 9i plus 10i, is just going to be plus I, so it's 21 plus I over 13. So 21 over 13 plus I over 13. So then we know that's the same as 1/13 I. So A is 21 over 13, B is 1 over 13. And A plus B is 22 over 13. That's choice D. So notice on the SAT, they don't just see if you can figure this out. You have to do the little tricky thing where you add these two coefficients together. That's a little obnoxious, but hey, that's the SAT. That's choice D. Did you find this video useful? If you did, please like it and subscribe to this channel. Neither action costs you anything, and you'll always be alerted about my new and always free videos. Why do I care? Well, YouTube doesn't give me any ad revenue unless I have 1,000 subscribers and 4,000 hours of view time in 1 year. So if you've seen an ad on my channel, please know that I got nothing from that. So you can help me get a share of this. I mean, I am creating the content. Seems like I should get at least a little taste of the ad money. I know YouTube is providing me a platform and all sorts of great things. So that's wonderful. But come on, help me out too. While many people are watching these, I don't have 4,000 hours of watch time and a copyright issue. I'm pretty sure this is all fair use. If you feel otherwise, you can contact me. I don't have anywhere near 1,000 subscribers. For the same reasons, you are not only welcome, but you're encouraged to share links to this video, put in playlists, etc. I'm always happy to read and respond to constructive criticism or suggestions for new videos. I reserve the right to delete comments from and block those who specialize in destructive criticism. Trolls or things that are off topic, whatever. Anyway, spammers, disturbed people, fine. If you're going to post crazy stuff on my page, I don't have to leave it there. Thanks for watching. Hope you have a good day. All right, bye.